Today you're going to build carbohydrates. We talked about these the other day in notes, and we talked about them as being energy givers and what stores energy and what you need in your diet to be a healthy person. So you're going to need 2 pink papers. You'll notice they look identical. 1 water droplet, a glue stick, and scissors. This is going to be a monosaccharide. It's only one. It's 1 carbohydrate. It's only going to give you a little bit of energy. What you're going to do is you're going to cut off the OH off the one end. That's going to bind with an H on another monosaccharide, and you're going to make water because 2 H's and an O, you know, makes water. Now, instead of cutting it off and taping it together, we're going to glue over top of it. So we're going to put glue over the H, and we're going to slide the first monosaccharide on top of the second. Okay, so yeah, it's disappeared. So 2 H's and an O makes water, and when you put 2 monosaccharides together, it is a condensation reaction. And in your notes, we learned that that was where water comes out. So there's our water. It drips out, okay? So now we have a disaccharide. A little bit more energy, and your neighbors also made a disaccharide. We're going to take both disaccharides, and we're going to put them together, and we're going to end up building a long chain, or a polysaccharide. These are going to give us the most energy. So again, we cut off the OH. We're going to take our neighbor's disaccharide. We're going to put it on top of the H, technically cutting it off, getting it out of there. We're going to glue it, and we're going to have another condensation reaction. That condensation reaction is going to make water, you guessed it. So we're going to take another drop of water, and we're going to put it on this reaction as well. Disaccharides, polysaccharides, are going to give you more energy than a monosaccharide. And if you look at it right now, you can see that they're all identical. We can have isomers, which means that it's the same chemical formula, but different chemical makeups. And if that's the case, then we have this polysaccharide. All right, so there's our drop. Now we're going to take this polysaccharide, and we're going to add it to a larger polysaccharide. So at the end, we're going to have everybody's carbohydrates put together in one long chain. Now, some of the longest carbohydrates that we have are from plant cells. This is called cellulose. This is going to give us the most energy. So when you want a carb load, you want to eat potatoes, you want to eat rice, you want to eat things from plants, because it's going to take longer to break them down, and it's going to give you more energy over a longer period of time. What comes out? You guessed it, some more water. When we make this chain, again, everybody's looks identical. That's going to be different from proteins, and it's going to be different from lipids. It's a ring structure, which is also different from proteins and different from lipids. So you guys are going to have to share what you've learned from the video and what you've made with the class when everyone gets done. All right, so thanks for listening, and great building. You've got your polysaccharide.